Is it going to start? There it goes. Yay! Well, here we are again. Welcome, everybody, to Astronomy Daily Live. So, hope everybody's doing well. Things are good here. Things again here are clear and windy, but I have a plan, and I'm going to talk about that a little bit today. And I think I figured out sort of a way to keep this live stream at the same time in the same place, without having to disrupt all of that. So yeah, we'll talk about that a little bit, and then move on to some other things. Maybe yeah, maybe just let's do what we were sort of talking about last night, and go over to Mars and take a look at Mars for a little while. I think that might sound a little bit fun, and we haven't been over to Mars in a little while. So yeah, I hope everybody's doing well. So I mentioned to Bobby in the pre-show that I've got a new little toy here, and here's another teaser there. But before I do that, I will say hi to the folks on the panel. So, Bobby, what is up?
Hey, nothing much, you?
Everything's good. Everything's good. Like I said, it's just it's clear and beautiful outside, but the wind is blowing. And man, that wind makes it feel cold, cold, cold. So, but yeah, other than that, everything's good. And we've got Tom on the panel too. Hey, what's up?
Hey, not too much. Just another winter day here. Let's go check out Mars. That sounds good.
Yeah. I think I like to go over to one or two different sites, maybe every month or so, because they usually do some nice updates, monthly or so. So, it's nice to jump over there and take a look at the latest thing. And I still, and maybe it's just my age, I'm not exactly sure, but I'm so incredibly amazed, right, that I can sit here, right? I can sit here, sitting around, nice and warm, cozy, everything else, right? And I can look at Mars as it was maybe one day ago, right? And it's absolutely mind blowing to me that those kinds of things can now be done, and the fact that we can, oh, hello there, is just sort of a side effect, right? It's the scientists, it's the engineers and everything that actually want that data. They are sort of kind enough to make it available, hello, to us in sort of a nice way, and it's incredibly cool. It's very, very, very cool. So yeah, for sure. Okay, so I've been waiting for this to arrive for at least a couple weeks or so, but it finally did. And this I probably built up a little bit too much, but it is pretty interesting, and it looks like it's going to work. So I am pretty excited about it. And what this is, I will now raise it above the thing here. This is called the Light Owl, and it is put out by a company called Stereoscopic company, and these were actually designed by Brian May, and I don't know if that'll focus on his name there or not. Anyway, I can take it out. Brian May, of course, is the lead guitarist for Queen. So it comes with a nice little cover here, a little set of instructions. You know, how to use it, and what this allows you to do is view stereoscopic images like that, right? The left and right things. And this in particular, there's cat hair all over it already. How'd that happen? How'd that happen?
What the deal?
Yeah, what's going on? I don't know how that happens.
Stupid cat.
But as you can see, these are lenses, right? I mean, it's plastic, right? But these are lenses, right? And the idea is that you can take your smartphone here and put a stereoscopic image up. And this is actually one of the ones that I made, right? And you can, I think you've got to be about like 5 inches away or so, but you put this up like there, right? And you get a beautiful, fantastic single 3D image. And these really work incredibly great, incredibly great. Now,
is that something that you could get on Amazon or something?
This I actually got from a site called I'm gonna look it up here. You can order it directly from the London Stereoscopic Company, but they have a distributor here in the United States. If you're in the United States, and I'm going to look that up really quick here because I never remember what it's called.
And maybe if you want, if you get that site up, you can share your screen. I'd like to see that site.
Yeah, okay. It's called the let's see, the site itself. Come on, machine, you can do it. It's called My Science Shop. But let's go over, since you asked, let's go over to the London Stereoscopic Company. But anyway, this is actually just one of a couple of different types. This is sort of the cheapest one. This is $5. $5 plus a couple dollars shipping. So I think it cost, almost $8 total. So it's a good deal, but it seems to sort of only work well with sort of smartphone sized screens, right? I tried to look at the same thing on my big screen here, and because of the lenses, because of the focal length of the lenses and everything, doesn't work. But they actually include in this a little thing of Saturn, and I'm sure that works really. Oh yeah, wow, that thing just pops right out of the paper. It's really amazing. So yeah, with this, you don't have to cross your eyes. You don't have to, do any of the funny things at all. You basically, put it on and, get your target up. It's about that close or so. So, I don't know, 6 inches, 5 inches or so. And these work really, really, really well. And the primary reason why this was sort of exciting to me is because I do want to do, you know, this kind of artwork, and I want to be able, you know, to show it off, right? I want to be able to make this available at, like, you know, some kind of an art show. But it's like, well, how can I let people actually see, you know, the 3D effect? Well, it's all they have to do is walk up to it, put these on, and they'll see it, right? And in fact, now that I know that these work, right, these work really, really well, the London Stereoscopic Company, which I will now share my screen on here.
And do they also have like the red and cyan glasses as well, or they just got those light owls?
I think we can look, but I think they just have the owls. Okay, so here's the main site, right? Here's the main site. You know, they have a bunch of these. You know, different stereoscopic things, but the one that I'm particularly interested in now, and of course, you know, they have Queen in 3D, of course, you know, because this is, you know, a Brian May site. Somewhere in here, OWL viewers, here we go. So let's see, this is the one I got, right? The light owl, which you just sort of hold. But this one here, which I'm going to zoom in on, right, is the whole thing. And you put your smartphone here, right, and then you look at it here, right. So in like a art show, right, you can have your smartphone sort of scrolling through all of your stereoscopic pictures, and people, you know, can walk up to it and just look through these, and it works really, really, really well. So yeah, I'm pretty impressed with this, and yeah, it works incredibly well. So yeah, it's kind of exciting. Like I said, sort of a new little toy, but yeah, I think that this is gonna be really, really, really cool, and it makes it super, super easy to view these things. And the cool thing is, right, is that you can zoom in, you know, really, really, really close, and so, you know, the picture looks absolutely huge. And yeah, I think it works really, really well.
There's actually two people. We got Starseed and Ron from Earth Radio in the chat.
Cool. Nice to see both of you in here. Yeah, I'm going to look. Hey there, Starseed. Nice to see you. And Ronald, hey, nice to see you in the chat too. Welcome. Hope everybody's doing well. I'm just sharing the news in my... Go ahead, Bobby.
Okay, so this is only just showing like the light owls or the owl viewers, right?
I think so. I think so. They are into the stereoscopic viewing, and not the other kind where, you know, there's a red side and a blue side. You know,
and
this actually...
Roberto has a question. What about those holographic art pictures that were so popular in the 80s? Is that an option for your artwork? And would that not be also a little more practical for an exhibition?
Well, actually, let's see. I'm gonna stop sharing. Hey there, Tim. Nice to see you on the panel.
Hi, Matt. How are you doing, buddy?
I'm doing good. I'm playing with my new toy here. So this is
your new telescope.
Yeah, this is my new my new telescope. Makes everything super clear.
I
And
had
we
you
like
off screen for a
to,
moment while I was setting up dual monitors.
yeah. Hey, Tim. Hey, Sue.
So,
I
Hey
I don't know
there,
if you heard her or
Sue.
not.
Yep, we did. We did.
And then we got Johnny Unitas, one of the regulars of Earth Radio.
Yeah. Hey there, Johnny. Nice to see you in the chat. So howdy. Welcome to Astronomy Daily
I'm just gonna
Live.
watch
So
a bit of
yeah,
it.
I'm just talking about my new stereoscopic viewers here that I just got. I was a little
Yeah,
bit
okay.
concerned that they weren't going to work, but wow, they work incredibly well. And as you can see, they're little lenses, right? So what you can do is you can take images like that, right? Sort of a left and right view, and you look at them like this, and it is completely 3D. It's absolutely fantastic. And I've been making my own, right? So I've been taking data from spacecraft. This is actually data taken with the Maven spacecraft, and I've created sort of a left and a right image, put it on my smartphone, and it's absolutely fabulous. It works really well. So I'm really pleased. I'm going to be able to show these off at some of the art shows that I want to go to, and using these, people are actually going to be able to see them. So very cool. And these work really well. And like I said, the London Stereoscopic company is actually selling these for £4.5, and plus shipping, I'm sure. Here in the United States, with shipping, it's about $8. So not bad. I mean, it's plastic, right? But right? Works really well. Definitely want to keep these in its little case, right? It comes with a plastic case because I definitely don't want to scratch up those lenses too much. So that's exactly what I'm going to do right now before I forget, because otherwise they'll drop on the floor and probably get stepped on. So very cool. Hey, I can see a Patrick Manny. So that's exactly what I'm going to do right now before I forget. And I can also hear a Patrick Manny.
Hello, Mr. Patrick. How are you diddling?
Hey. Wow, we got this is the most full panel that we've ever had. Very cool.
And I
Very
think,
cool.
Patrick, is your telly on? Is your TV on?
Patrick, how are you diddling? Someone's
Yeah,
TV is on,
I'm getting an echo from Patrick. Echoes.
It's not only Cosmic watching them porn channels now, it's Patrick too.
All of us. Yeah, all right.
And speaking of all of that, I think we better test out a command here.
All right. Let's do it. What command are you going to
Tom,
test
by the way.
out? Yeah.
Hey, Tim.
It's nice to have a nice full house. So I guess the only thing that I can recommend for the panelists is either make sure that all your sounds are sort of turned down, or just mute yourself unless you want to talk, and feel free to cut in anytime you want, because this is what this is. This is sort of a virtual porch. We're sitting around. I've got the coffee here. I've got the hydrogen hydroxide here. So, grab your choice of consumable and sit back and enjoy. So yeah, hope everybody's doing well. So yeah, great thing. I'm not going to have to cross my eyes anymore to actually view my stuff. Although most of the creation I'm doing is on this screen, so I'm still going to have to do it. But you know, as soon as I put it onto the smartphone, these will come out, and I will do that. So very cool.
Got faucet H2O. Cheers.
Yay!
Faucet
Courvoisier brandy and lemonade.
All right. And it's kind of cool. I think they sort of intentionally made these sort of the same size as a smartphone. All right. So that's kind of neat too. So great stuff. You know, if you're into those kinds of things, I you know, because I'm sort of, you know, getting more and more into this artwork stuff. And a lot of the artwork that I have can be three-dimensional. I am definitely going to dive into this much deeper, you know, because what I've been doing recently is just sort of messing around a little bit. For instance, this image behind me here, okay, that image can be made into a 3D image, and so I'm pretty excited now, you know, to start working with that and seeing what can be done. Not only, you know, because it looks really cool, but this is actual astronomical data, right? You know, this isn't, you know, I can't draw, right? I can't draw for anything, right? But writing a little bit of code, you know, to read some data and draw some lines and some dots and everything, that's what that is. So you know, I just
say, like, anybody that's gonna be like is gonna do something like that, I think we all need to get those albums.
yeah. Well, you know, I think I posted some of those stereoscopic images over on the Discord server. So feel free, you know, to take a look at those. You know, grab them, put them on your phone. You can definitely do, you know, the cross-eyed thing. I mean, that works really well. Sometimes it takes a little bit.
There's Chris Elliott from Elliott Astro Imaging.
Hey there, Chris. Nice to see you. Cheers.
Nice guy. Cool guy.
Chris is absolutely fantastic. Yes, and you know, his pictures are some of the best I've ever seen. They're you know, they are definitely done with care. He's got a really great system that tracks really well, and there isn't any kind of funny stuff, you know, out here on the edges, right? One of the first things I do when I look at those kinds of photos is I look at the edges, right? Because that's where all the nasty stuff is. And when I see nice round stars, right? They aren't donuts, and they aren't, you know, elongated things and all of that. If they're nice round dots, that tells me that one, you know, he's got a great system, and two, you know, the processing that's done is done, you know, with a lot of care, a lot of attention, and you know, the pictures that he makes are
stacking that he does. It's brilliant.
Yeah. You know, it's all great stuff. So absolutely. So yeah, so nice to see you, Chris. So yeah, I think, like I was saying, I think you know, in sort of following the conversations that we were having yesterday, let's go over to Mars and take a look at sort of the recent newest Mars pictures. And I'm trying to decide if we should, I guess probably what we should do is start with Curiosity, and then sort of move on, if there's time, go over to High Rise. So I'm going to pull up the Curiosity raw images, and I put that in quotes because they're not really raw images. They've been processed a little bit, turned into JPEGs, all of that. But I think it's called the Mars Science Laboratory. That's its official designation. So we're going to go over there, and as soon as that pops up, I'm going to share my screen, and then we can just sort of go through this here. I like to do this, from time to time, maybe every month or two, just to sort of, catch up on stuff. And like I was saying, I think it's absolutely amazing, that we can sit here, comfy, and look at Mars, right, at the surface of Mars. So,
and I never heard that there was a meteor strike that hit the moon during the eclipse.
Oh yeah. That was a piece of news that I heard this morning, and now let's be a little skeptical here, right? Let's be a little bit skeptical. There was a flash, right? There was a flash that looked like it was on the moon, right? It was in sort of the disk of the moon, right? Now they immediately say some kind of an impact, which it probably is. It probably is, but basically, it's all we saw was a little flash, and actually, those happen pretty often, right? There are at least a couple of groups now that are pretty much continuously watching the moon for these flashes, and I'm not sure if it's some kind of an impact, or if it's some kind of an electrical event. I don't honestly know. It's probably an impact, but and I think they've actually gone back and looked for markings and things there, and I think in a couple of cases they've actually seen that. So yeah, it probably is an impact. But really, honestly, what was seen was just a flash, right? And like I said, these things are actually happening almost all the time. I forget exactly what the numbers are, but once they started looking at these things or for these things, they're seeing them going off pretty frequently. But yes, I totally agree. That was very, very cool to actually see one almost exactly at mid-eclipse. I think the timestamp I saw was like 4:41:42 or so UTC. So and I think it just appeared in like one video frame, right? So I mean, these things happen really, really, really fast. But I think it's very, very cool that that happened then. So yeah, if you haven't seen that yet, check it out, because it's extremely cool. All right, so here is Mars. Now, the first question that I have is, they organize these things by sols or sols, and a sol is a Martian day, right? So, and a Martian day is slightly longer than an Earth day. I think a Martian day is something like 24 hours and 40 minutes, Earth minutes, something like that. It's a little bit longer than an Earth day. So Sol, for instance, here, right? It says Sol. Whoop, come on, Sol 2297. So that isn't the 2297th Earth Day that Curiosity has been on Mars. It's actually the 2297th Mars Day. So yeah, we can actually find out exactly. Can we do this? Let's see where is Curiosity. So I think this can give us an indication. Okay, so right now we're on Sol 2298, right? And we can actually go and look here and see where it is. It looks like they have they updated this? This is going backwards. So yeah, it looks like they haven't updated recently, right? They have a shot here, probably taken with the high-rise imager, showing about where it is. But this is as of Sol 2257. So that was a little while ago. But now at least we know what day it is on Mars here. So it's 2298 is sort of the current day. So now we can go back to the so-called raw pictures here and see that we have images from just one Martian day ago, which is absolutely fantastic, right? So they got a bunch of cameras on this platform, this rover. The avoidance cameras, which are sort of looking down and looking forward and rear, just to make sure there aren't any rocks or holes or traps or what are those things called? The mines, anything like that, because we don't want to roll over any of them. Small cameras looking around, right? We've got the navigation cameras, which are left and right. So these are really, really cool because you can actually make stereoscopic pictures from these. And that's how they do it there too, right? They take the left and the right, they combine them, and that allows them to see depth, which when you're moving around, it is a great advantage, to be able to see depth for sure. And yeah, they've uploaded a bunch of images from yesterday. So yeah, we should definitely take a look at those. And they're nice enough here to actually locate them on the rover too, right? Here's the left one, here's the right one. So that is very, very cool. And I actually have made these into stereoscopic images, and yeah, it works really, really well. I need to do a little bit more of that now. I put them on the smartphone here and see how nice those actually are. So they got a few more cameras. Go ahead, Bobby. What?
And Tara Robinson is right there. Channel sees all. And he said like his camera is picking up some good colors on the moon.
Cool. Nice. Nice, nice, nice.
No, I don't have his channel.
All right. Moving on. So, you know, there are a few other cameras. I guess the Mars descent camera is still operational, although that one I think is just sort of, you know, pointing straight down. It's also really, really nice. You know, they give, you know, give us a little reference here. You know, this with a, what is that? A Swiss Army knife. So, you know, you sort of get a sense of the size of these cameras. They're not really, really big. They're just sort of normal size cameras, right? You know, they're not really, really tiny. They're not really, really big. And then, of course, they have, you know, the mass cam, which is the one way up on top. I think that's part of this apparatus up here. I think this is part of the mass cam. Of course, this thing here is you know, put inside of this. So very cool. And let's see. Well, they don't have anything from 2297, but they got some stuff from 2296. And I think, I'm not exactly sure. I think the navigation cameras and the mass cam are also multi-wavelength, right? So I think there's, and we'll look here, but I think there's like 5 filters with the mass cam, and maybe 3 with the navigation cameras. I don't remember exactly, but yeah. So let's look at the surface of Mars here. Let's look. Let's use the left nav cam, and I'm just sort of choosing that because it's the latest day and it's the biggest number, right? That's all. So let's see. A lot of these, you know, are, well, they're all extremely cool. Not all of them are extremely interesting, but they're all pretty cool looking. So let's see. Let's just let's see. Is there any? So here's a picture of the RTG. You know, the power supply for Curiosity. Here's a bit of the wheel. Let's just look. Let's get some spacecraft, or, well, rover views here. So, oh, I should have popped up the full resolution thing. Let me do that. Wink, because that will pop up a new window, or at least it should, theoretically. Maybe. Did it show up somewhere else? Yeah, there it is. All right, so here we go. So yeah, there's a little bit of the rover there. This is the power supply. It's a radioactive source that provides, I forget how many watts. There's quite a few watts, maybe 300, 400, 500 watts. I'm not exactly sure. Maybe even more than that. But yeah, there's a little bit of the rover there. I always like looking at all the wires and the screws and the bolts and everything, right? Just out there roving around on the surface of Mars. It's it's just amazing, absolutely incredible. Not quite sure what this is. Maybe it's some kind of weather station, you know, some kind of thermometer or something. It's hard to tell. Hard to tell. But, you know,
morning.
What's that, Tim?
I wouldn't want to have to start that up on a morning.
Yeah. Anyway, I always think it's really, really cool to see all these wires and how they're, you know, bound up and everything. And yeah, what an amazing device. I'll pop up another one here. For some reason, it's not coming up exactly. And again, I don't recall exactly what these instruments are, but of course there's something else. You can see in the background here, there's
Hmm.
kind of hard to tell a little bit there, but some kind of a flat raised area there. That's kind of cool looking. All right, cool. Let's we can take a look at least a piece of one of the wheels. And, you know, just rocks and dirt. Rocks and dirt. That's what Mars has. But a lot of these things are pretty bright, right? It looks like the solar angle here is pretty high, right? So you know, the sun looks like it's sort of coming, you know, almost right overhead, but a lot of reflection, a lot of bright stuff here. So that's pretty cool. This is kind of an interesting feature here. I'm kind of curious. Huh. Yeah, you know, our brains, they latch on to, you know, right angle things like that. That's kind of interesting. I wonder how that happened. I don't know. Who knows? Who knows? It's you know, the geology of Mars and how it sort of got how it is now is still you know, quite a bit of a mystery. You know, we're seeing, you know, layering, right? That sort of looks like a layering thing up here. Kind of hard to see, I guess. But so yeah, it's just it's a busy place, right? And you've got rocks of all different shapes and sizes, and you know, some of them are really dark, and some of them are really bright. You know, and I don't know about you, you know, but when I'm outside looking at the ground and looking at the rocks and the dirt, I sort of see the same kind of thing, right? It's you know, there's a large variety of sizes, shapes, colors, all of that, and this sort of looks you know, almost familiar, right? Here's kind of a triangle shaped one though. Look at that, that's kind of cool. All right, let's move on here. Anything else? It's always nice to sort of see the horizon. It's kind of a cool view to see the horizon off in the distance. You can see hills and things, and this to me looks like home, right? I mean, you know, you know, put some trees and, you know, bushes out here, and it looks like, you know, my backyard. So, you know, with the hills and stuff, yeah, it looks just like home to me. So very, very cool. Very, very cool. Yeah, but it's a very different place. Very different. So they have a bunch of subframes too that they grab. Here, let's just look at another piece of ground here. Yeah, just rocks and dirt. But it's Mars, right? And you know, Mars is now an actual place, right? I mean, it isn't just a point of light in the sky anymore. It's a place. And it's probably a place that we're going to go. Probably. Don't know if we'll stay. Don't know. You know, the conditions are pretty harsh, but you never know. And these are called downsampled. I guess these are just maybe lower resolution pictures. Yeah. You know, they're just smaller shots. You know, they try to. Well, you know, they have a limited amount of time to download all these pictures. And so, you know, they have to be sort of picky in terms of what they grab and what they don't. My guess is that all this data is actually being stored on board. Here's sort of a sequence, right? You can sort of tell that it's a sequence. Don't know if the rover is moving or if it's just panning, but this dark object, whatever it is going from right to left, right, in these four panels here. So not quite sure if that's a panning thing. This is probably just calibration stuff, flat fields, just like doing flat fields here, when you're doing any kind of telescopic stuff, they've got to take all their flat fields up there too, because they want their data to be well calibrated, right? And they have a bunch of thumbnails too, which are just tiny little things, right? All right, cool. Let's keep going. Let's look at the right hand ones. Let's actually get a time stamp on one of these, right? So this is, I believe that this is Earth time, right? Because it says UTC. So let's just see if they made a right and a left image of this first one here. So here's a left one at 9:57:34. Let's go over to the right hand one and see if there's a similar one. It should have been taken at about the same time, same date, same time. Yeah, there it is, 9:57:34 exactly. So we could actually take this image and the left image and put it in view if we wanted. Maybe we should do that at some point. It probably, well, yeah. As long as you're willing, to cross your eyes, we could do that. But not. I don't think I'm going to now. So sort of the same kinds of views, right? They're just snapping pictures, just snap, snap, snap. They're madly snapping. There's a shot of that flat area back there. Well, it doesn't look too flat. It looks like it's just maybe in shade or something here. So yeah, kind of cool. Looks like there's a larger rock there. That's pretty cool looking. Pretty nice. Lots of rocks. But here's see this bright stuff here? That's, it's like, why is this so bright and everything else is dark? Are we seeing, deeper into the soil? Is it just a shiny rock? And if it is a shiny rock, it's like, well, what's making it so shiny? I mean, it's got to be, some kind of different kind of material, either that or it's really, really flat, right? Really, really flat.
Perhaps there's some kind of metallic materials close to the surface.
Yeah, yeah. I don't know. So this live stream is a lot of me and or us just thinking out loud. So have absolutely no idea at all. I'm sure somebody has lots of ideas about that, but I always think that is kind of interesting, right? All right. Well, this is sort of the same kind of thing as we just saw with the left. Let's go back in time a little bit and see what else. What I usually do is just sort of look for a lot of images. So let's just go back in time here. And of course, this goes all the way back to Sol 1, right? So you can look at the first images taken. Let's do that. So these were the first ones taken. Look at that. Woohoo! That's how it
Give
goes.
or take with my phone.
Yeah, yeah, yeah. That's about right. That's about right. Let's now this poor thing I'm gonna really make work here because I'm gonna go back. Let's look at Sol 2. There's a few more images there. There might actually be an actual picture. Yeah, there we go. So they took a bunch of pictures of the rover itself, right? Making sure that everything is okay, I assume. So yeah. And this is kind of interesting too, because what you can do, right, is you can look at these kinds of pictures just after it landed, and then look at the same areas now and see how things have changed. How much dust is accumulated, or wear and tear on the wheels. They for a while there they were rolling over some really really nasty stuff, and look at all that dirt on there. Look at all that dirt. So
Look at all
this.
that. Wait.
Yeah. Well, this was this. I'm pretty sure this was some kind of a powered landing, right? So they're throwing up all kinds of stuff, right? So I'm not surprised, right? That you've got all this
Do you
dirt and
mean
everything.
from like a kind of a thruster underneath, throwing
Yes.
all kinds of debris up? Yeah.
Yeah. So yeah. Again, I like to see all these wires, and how they're tied up and all that, and just exposed, right? They're just out in the open. Ah. All right, well, cool. Yeah. So yeah, this is one of the cool things about this particular site, is that you can go all the way back, right to the beginning, years and years, right? This has been up there for a long time now, and you can go all the way back and take a look at any of these, right? Any of them. Let's see, is there another one here maybe we can take a look at? Let's do the right one. Here's 168 of them on Sol 2157. Let's take a look, see what they were looking at there. Here's it looks like the actual tire tracks. Whoop, did I grab the wrong one? Oh, no, I didn't. It's just a zoomed in view. Yeah, so there's the tire tracks, right? So sort of looking back from where they were coming from, right? So can you imagine this thing driving around on Mars? It's just, and actually seeing that. Wow, what a sight. What a sight. And what a view.
What kind of delay do they get from instructing a command to the module to drive, say, that distance, and it actually happens?
Probably what they do is what they do with most other rovers and spacecraft, is that they'll send up a series of commands, and it'll just run through those instructions, right? But depending on how far away Mars is, the light travel time, I think varies. And somebody in chat or somebody on the panel, can help me with this. But I think the light travel time varies between like maybe 15 minutes and 30 minutes or something like that. It's something like that. Don't quote me on those numbers exactly. But yeah, there is no real time control at all. So,
the reason I asked that is because I was kind of wondering, do they try to do it real time and then wait for the action to happen, or do they pre-send them with a predetermined time for it to happen?
Yeah, it is the latter of those two, right? You know, they have teams of people looking at these images and saying, okay, where are we going to go to next? What are we going to look at next? And so all that is planned, discussed, argued over, and then those commands are sent up and ran. So yeah, it's sort of an automated thing, to a certain extent. But yeah, cool.
And
very
what
cool.
controls the rover today?
What controls it?
Yeah.
Do you mean who controls it, or
Like
what?
Like who and what?
Oh, it's probably gone through JPL, and there's a team, right? There's a team of people who it's their job, to run this thing, and so they do, yeah. That's their probably full-time job.
It looks like it's between 3 and 22 minutes to get signals to and from Earth and
okay.
The rovers.
Gotcha. Cool.
It's not bad considering.
Yeah. There is no real time here at all. Yeah, because light travel time, even 3 minutes, right? That's just there. That is way too crazy, to want to try to do that.
Now, is it true when they do when they did the Apollo missions, they can really do some voice and data communications within about 15 to 30 seconds? Is that possible? Or
well, the light travel time to the moon is like 1 second. So that isn't quite real time, but that's sort of good enough. So yeah, for sure.
Yeah, you can drive a rover on the moon from Earth if you really want to.
Yeah.
You can't do it on Mars. It's
I want to know.
Yep.
We all want to.
Yes. Well, hey, I definitely want to put a telescope on the moon. I think that would be extremely awesome, and you'd be able to operate it, just like a remote telescope, here. That is definitely a project that I want to get involved with. There is actually a group that is working on that. They have some kind of a small telescope on the Mars Express spacecraft that's going to land near the South Pole, and there's going to be some kind of telescope on that. I don't have a lot of details about that yet, but that's a good first try. And actually, it's a second try. Actually, the Chinese, their previous lander, the Cheng 3, that has a I think it's a 150 millimeter telescope on it. And that has been running since 2015, and it is still operational today. And they're getting science and all of that. Haven't been able to get any of the data yet, though. I'd love to see it. To see that.
And is it possible that when you're on the moon, you actually can't see the stars, or can you see the stars?
You can absolutely see the stars. Absolutely.
Oh.
100%. And there's no daytime or there's no daytime, because there's no air up there, you know, to scatter the light and make a blue sky. So, you know, the sky is always dark. You can always see the stars. Now, you know, you've got a bright sun in the sky and you've got a bright earth in the sky. But as long as you don't look, you know, too close to those, you're gold. This is some nice, interesting. I don't know if they would characterize that as sort of like granite, or not exactly sure. But
This
look
all
at
rover footage that could also be taken from thousands of miles away. I can't tell.
This is the rover. Yeah, this is on the ground.
Right. Thank you.
Yeah, you know, that's actually one of the problems, you know, with these kinds of pictures, is that it's really hard to get a sense of scale, right?
Yeah,
I mean,
there's
you know,
nothing there that you can recognize by size.
yeah, you know, is that a huge 100-mile long boulder, or is it a little tiny rock that you can hold in your hand, right? You know, well, I can say for sure that, you know, this is, you know, sort of a sizable rock, right? You know, but you could probably hold that in your hand, right? But it's hard to tell exactly, because, you know, we really don't know, you know, from this what the distance is, and of course, you know, the size. That's why having a left and a right is very cool, because you know the distance between those two cameras. You can measure the parallax and know exactly how far away all this stuff is. So yeah, that was a brilliant move, and I think all the landers that I'm aware of did have that ability, right? You know, they had sort of a left and a right, you know, to be able, you know, to get their scale. Yeah, you know, because otherwise it's like, you know, is this 1,000 miles away, or is it, you know, 1 foot away? Don't know. But, you know, because this is the rover, you know, we know that this is relatively close. And then, you know, of course, it goes further away back here, right? But really interesting structures here, and cracks and crevices, and pretty wild, pretty wild place. Looks like this one's looking a little bit more down. Yeah, so here's a piece of the spacecraft here. They've got all their calibration things and all of that. So here, you know, you get a pretty good sense, you know, that these are really close to the camera, right? You know, a couple feet away. That's kind of an interesting looking rock there. Pretty cool. All right, let's move over to the mass cam, because the mass cam sometimes has some color images. I thought the navigation cameras had filters on them, but I'm not seeing, you know, multiple black and whites of the same thing. So maybe these are just grayscale, but I know for a fact that the mass cam does have a bunch of filters on it. This, which is probably hard to see. I'm going to try to zoom in a little bit here, a little bit more. There's a filter wheel back here, which it's kind of hard to see, but you know, they can take a, you know, they can rotate a filter in, you know, like a red filter, take a picture, rotate it, you know, to a blue, take a picture, rotate it to a green, take a picture. I think they actually have like 5 filters on this thing. So what we'll oftentimes see with the mass cam is either, you know, color pictures like like these, or we'll see a series of 3 or 4 or 5 pictures that are in grayscale. So these are those kinds of things, right? They've got, and maybe there's even more than 5. I'm not exactly sure. 1, 2, 3, 4, 5, 6, 7. Maybe there's 7 of them. I'd have to look that up. But as you can see, this is exactly the same shot over and over and over again. But the grayscale changes depending on what filter is used.
I guess that actually tells you they don't use the mass cam pretty much.
Well, the mass cam can gives you color, and color information is really, really, really nice to have, right? Because that's spectral information, and spectral information is extremely useful. So here's some holes in the tires, right?
Cool shots.
Yeah. Look at how it's all dinged up and bent, and yeah, actually these holes, I guess, are the intentional ones. There are some that aren't. Yeah, like here's one, right? There's a big chunk out of that thing. Yeah. Early on, they were rolling over some really, really sharp rocks, and they started noticing all these holes, and it's like, oh shit.
Is the rover especially heavy?
They're really sharp, and the rover, yeah, I suspect that it's pretty heavy. I don't have those kinds of numbers in my head, but
because I was thinking that they'd obviously try to make it as light as possible, plus it's in less than Earth gravity.
Correct. True. But still, these rocks are like really, really, really sharp. And so, after they saw several of these holes, they're like, okay, well, I guess we won't roll over those kinds of rocks. Yeah, here's I think a big chunk out of this one.
That's huge.
All those cracks and stuff. Isn't that awesome? So it's like, don't do that.
So I guess
it'll take the gravel out of the tread.
Yeah.
It's very, very sad there's no service stations or something like that in Mars.
Yeah, get your gas here.
Not yet. Not yet. Coming soon to a planet near you. So yeah, these are used to calibrate the cameras, right? These little devices have different colored spots on them, and as you can see, this is a Bayer image, right? So it's sort of the typical Bayer pattern, but these spots and these different parts of this thing are different colors, and so with one filter it'll look like this, and with a different filter it'll look like that, and in so doing they can calibrate things.
So they're using it as like a test card, like
it's a test
the old
card.
TV test card that you used to get.
It's exactly the same idea.
Right.
Exactly the same idea.
Makes sense, actually.
Yeah. Well, in order to do science, you have to calibrate all this stuff. You have to know what you're looking at.
And Uncle Bill Duran's got some comments. If you would check the chat,
he does. He does, huh? Let's see. Yeah. Yes. Yeah, that was sort of a learning curve too, right? So, okay, well, Patrick, you've posted a link to a video that's saying that you can't see stars on the moon, so they say. So, I'm gonna have to check that one out.
A lot of people say that.
Yeah, yeah. I don't have a lot of information on that, so I'm extremely curious. Yeah, yeah. Well, the Apollo photos, those cameras and systems were were used, to photograph the surface of the moon, which relative to the background sky is incredibly bright, incredibly bright. So they had to stop those cameras down enormously, and as a result of that, yeah, I think all or most of the Apollo pictures, you can't see any stars, mainly because it's just the cameras have to be stopped down so much. So we'll see though. Like I say, you've got to keep an open mind, be skeptical, and be very curious. So that's what it's all about.
Regardless of all the conspiracy theories, who in this channel actually believes that those missions actually took place? Because I do. I believe them 100%.
Yeah, I mean, they're
Absolutely, I absolutely believe they happened.
I think so. Yeah, I don't really think that there's a legitimate doubt about that. So there is definitely some funny stuff, right? There's sort of some really interesting things that may not have sort of a reasonable kind of an explanation, but I think if you dig a little bit more, there are some pretty reasonable explanations for at least most of those things. So is it possible that that was staged? Absolutely, absolutely, of course, right? Was it? Probably not.
Massive
we were in a
just to disprove something.
Yeah, we were in a space race with Russia. If they faked it, Russia would have called us out on it. They wouldn't have let it go and said no.
Definitely.
They believe. Yeah, there's other countries that would have said no. You guys didn't send anything into space. We didn't see anything going on.
Yeah.
That makes total sense, Tom.
Yep. Anyway, so yeah, as you can see here, these pictures usually come in sets of like 5 or 7. So I'm seeing 1, 2, 3, 4, 5, 6, 7 of exactly the same. But again, same thing, just changing filters, right? So we could actually, and I think I've done this on a couple of live streams where we grabbed 3 of these at least, put them into GIMP, and colorize them, and that's something that can definitely be done again. So it's kind of nice to see them colorized. All right, well, cool. There's some. I'm not quite sure if these. I saw these before. I think these are images of the sun. I think. Pretty sure. Can't be exactly sure. These look like flat fields, with the different filters. So cool. Very cool. All right. Well, I'm looking at the time, and I'm noticing that it's getting a little past time.
3:15 a.m. here.
Yeah, 3:15 a.m. for Tim. And speaking of 3:15 a.m., um, my weather conditions. Oh, I'm going to stop sharing. Are sort of dictating a change in how I'm doing my telescope stuff. Um, Early evenings here have been windy, and that's sort of a typical thing for spring. So I'm sort of moving into my spring already, and that means that the wind blows. The wind blows. It usually starts to blow around noon, and it usually stops around midnight or so. So,
which means it sucks.
which means it absolutely sucks, especially because it right now, right outside, it is beautifully clear, right, and the wind is blowing. Well, when the wind is blowing, it jostles the telescope around, ding 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 ding, right? Can't do anything with that kind of data at all. So what I've decided to do is sort of change my program around a little bit, get up early, and spend 2 or 3 hours outside in the early morning, making observations. I'm going to have to take my calibration data at sunrise. Sunrise here right now is taking place at about 7:21 a.m., which means that I need to start taking calibration data probably like around 6:30 or so. So if I want to have at least a few hours of actual sky time, I need to start observing about 3 or 3:30 or so. So that is sort of the plan for, well, here I guess it'd be tomorrow. I'm going to get up around 3 and drag all this stuff out. You know, I'm completely blessed, right, in that I don't have to, um, um, pack all this into a car, drive somewhere, unpack it all, all that. No, I just have to go right outside my back door. So, yes, that is extremely nice. But still, I've got to lug it all out there, and I'm not complaining. I'm just saying, set it all up, and yeah, I'll probably have a nice clear, non-windy, but very, very, very cold, 3-hour run, and we'll see how that goes. But what that means is that right after I end this live stream, I am hitting the sack. Getting some sleep, before that, because
Me too, bro.
I'll be up. Yeah, for sure. All right. So with that said, I'm going to get out of here for now. So thank you, panel, for coming in. This is really, really great. I really like to see a nice full panel underneath here. Ding, 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 like that. That is really, really great. And like I said, panelists, make sure to jump in anytime you want, because I'm just going to keep talking and talking and talking. So barge in. Don't think it's rude, because it's not, right? We're sitting here on a porch. We're having a conversation, just having a good old time. So feel free.
As long as the porch heater's near my skin, I'm happy.
There you go. There you go. Yeah. Very cool. All right. Well, for now, I'm going to get out of here. And yeah, I'm hoping that this new schedule is going to work out such that I can keep this time slot for the live stream. I think that might work, at least right now. Now, when we're moving into summer, right? sunrise is going to be getting earlier and earlier and earlier. So yeah, maybe things will change, but lots of conditions outside are going to change too. Play it by ear. That's all. That's all. And that's that is sort of the astronomical way anyway. So you have to live with and work with nature, and I think that's a cool thing anyway. So, all right. Well, I'm going to get out of here for now. So, cheers, peace.
Thank you, Matt, and thank you, guys.
Thank you much. Yeah, yeah. And I will see you again in a little less than 23 hours from now. Just a little less than one little spin. So hold on to your hats. Don't get too dizzy. And I think there's a pretty good chance that we'll all be back here tomorrow. So very cool. All right. Take care, everybody. I will
Thank
see
you again,
you
Matt. All
later.
the best.
Yep, you bet. Bye.